Hi, good evening. I'm Nicole T. Laserna from NS1A3, and I'm here to you to perform the assessment number 5, which is all about solving the great circle distance, the initial course, the final course, the latitude vertex, the D-lobe vertex, track the great circle in every 10 degrees, and total distance of the track. So the scenario is you are going to determine the waypoints to use along the Great Circle track GCT from 35 degrees north, 7 degrees west to 39 degrees north and 74 degrees west. So first is we need to get the lat 1 and the long 1 and the lat 2 and the long 2. So the first one is departure position. So our lat 1 is 35 degrees north, 5 degrees north, and our long one we're gonna be is equals to 7 degrees 0 west, and the arrival position, the lat 2 is gonna be 39 degrees north, and the long 2 we're gonna be the of course 0 there you go, 74 degrees west. So it's lat 1 and long 1. So the next step is we need to get the D lat and the D long. So here you go. So the D lat is if they are with this if they are same with the same north, if they are same, and if it's not, if they are same, you're gonna minus it, and if they are not, you're gonna add it. So they are the same sign, so it's gonna be 35 minus 39 will gonna be 04 degrees. Of course, copy the sign north, and D long of, so same sign again, so we're gonna minus it. So 7 minus 74 is equals to 067 degrees, 0 and of course west. So the next one is we need to find the great circle distance. So here we go, the great circle distance. We're gonna write first distance. So we're gonna write the formula. The formula is cos GCD is equals to cos lat 1 times cos lat 2 times cos d lo plus or minus sin lat 1 times sin lat 2. So that is the formula of the great circle distance. So first we're gonna write the cos lat 1 is equals to 35 degrees 0 0.0. So to get the answer, so of course we're gonna need a scientific calculator. So we're gonna press the cos and 35 degrees. So the answer will be, so that we're gonna write the answer here, 0.81915. So we're gonna write the cos lat 2. The cos lat 2 is of course 39 degrees. So just so it's just the same. So we're gonna press cos and 39 degrees is equals to 0.77715. So we're gonna get the cos d lo. So our cos d lo is 0.67 degrees 00. There you go. So it's just the same. So press the cos and Write the 0, 67 degrees. So the answer will gonna be 0.39073. So if you all get all of them, so you need to times them. So we're gonna times them all. So 0.81915 times 0.77715 times 0.39073, and there you go, is equals to 0.2487 round off 4. So that is our that is the answer. So the next one we're gonna get is the sin lot. Sin lot 1 is equals to 35 degrees. There you go. And you're gonna get a calculator. So we're gonna press, now you were gonna press the sin, and of course 35 degrees. So it's just the same. So the answer we're gonna be 0.57350, of course round off 8, and we're gonna get the sin lot 2 is equals to 39 degrees. There you go. So it's just the same. Press the sin and 39 and press the degrees and equals to. So that's the answer. So 0.62932, and of course we need to times it because it's written in the formula there. So 0.57358 times 0.62932, so it's equals to 0.3609, of course round up 7. So now we get the answer of the cos lot and the sin lot. So we're gonna add them. So we're gonna write 0.24874 plus 0.36097 is equals to, so let's calculate. So 0.24874 plus 0.36097 is equals to 0.60971. So it's not finished, so we're gonna do something like, so to get the distance angle we need to write, of course, 0.60971. So we're gonna press the shift, cos, and answer, and the degrees. So that is our distance angle. So our distance angle will gonna be is 52 degrees 25 and 53.27. So we're gonna divide it to 60. So 53.27 divided by 60 is equals to 0.88, or if we round off, the answer will gonna be 0.9. So that is our so that is distance angle. So the distance angle will gonna be 52 degrees, and of course we divide by 60, so we're gonna get the 0.9. 52 degrees and 25.9. So that is our distance angle. So we need to get so now we will get the GCD. The GCD. There you go, the GCD. The formula of the GCD is the distance angle times 60. So our distance angle is right there, is 52 degrees and 25.9 times 60. So to create a great circle, distance is 52 degrees and 25.9 degrees is equals to there, and times it to 60. So that's the answer, 3,145.9 nautical miles. So now we shall get the initial course. So the formula of the initial course is sin initial course angle is equals to cos lat 2 times sin dilo divided by sin distance angle. So first we're gonna write the cos lat 2 is equals to 39 degrees, and we're gonna solve it. So just like how we did before, so we're gonna press the cos, and 39 degrees is equals to 0.77715, and we're gonna write the sin dilo. The sin dilo is 67 degrees. So we're just gonna solve it. So we're gonna write the sin, and 0.67 degrees is equals to 0.92050. So just like we did before, we're gonna times it. So 0.77715 times 0.920, so 0.77715 times 0.92050. So if we're gonna point it to decimal, it's gonna be 0.71537. So there you go, there the decimal right there. So there you go. So we're gonna continue. So we're gonna get the sin distance angle is equals to, the sin distance angle is equals to 52 degrees and 25.9 So just like we did before, we're gonna do the sin, and 52 degrees and 25.9 is equals to 0.90. There you go, we're gonna change this to degree. So the sin distance angle is 52. So sin distance angle, so sin again 52 degrees and 25.9 degrees is equals to 0. So the answer is 0.17963. So the answer is 0.7963. And that's not all. So first we're gonna do, so we're gonna write the 0.71537, and we're gonna divide it to 0.72963, so because it's in the formula. So we're just gonna divide it, so the answer will gonna be 0.71537 divided by 0.79263 is equals to, so we're gonna change to more, so we're gonna put into decimal. The answer will gonna be 0.90253 northwest. We're just gonna change it, so there you go. So that's not the end of it. So 0.90253 down. So that's the answer. So first we're gonna go press the shift and sin, and answer equals to, so the initial course angle is gonna be 64.493 northwest. So that's how you do it. So the next one is the quadrant rule. So the quadrant rule, so the formula of the quadrant rule is the northwest equals to 360, course angle is equals to true course. So northwest will gonna be 360 minus 64.493 is equals to, so we're gonna calculate. So 360 minus 64.493 is equals to 29,295.507. So our initial course will gonna be 295.507. So now we should get the final course. So there you go. So the formula of the final course is sin final course angle, there you go, is equals to cos lat 1 times sin dilo divided by sin distance angle. So of course the cos lat 1 is equals to 35 degrees 000.0. So we already solved it. So if I'm right, the answer of cos lat 1 is cos lat 1 35 degrees is, yep, I'm right, it's 0.81915, and our sin dilo is 0.67, just like we did before. Our sin dilo is, so first we're gonna press the sin and 0.67 degree, so our sin dilo is 0.92050. Of course we're gonna times it, so 0.8181915 times 0.92050 is equals to, so we can check it, there you go, is equals to 0.75403, right there, right, the decimal right there. So now to get the sin distance angle, we're gonna write 52 degrees and 25.9. So we're gonna press the sin 52 degrees and 25.9 is equals to 0.72963. So we now get the two answers. So 0.75403 divided by 0.79263 is equals to, so we're gonna calculate, so 0.75403 divided by 0.72963 is equals to, there you go, the decimal, 0.95130. So that's not also 0.9595130. So we're gonna go shift and use sin again. So first we're gonna write 0.95130 0.95130 shift, and of course sin the answer, there you go. So the final course angle is equals to 72.045 seconds. So now we're gonna write the quadrant rule. Quadrant rule is equals to SW is equals to 180 plus course angle is equals to true course. So SW plus 180 plus, of course, our course angle is 72.045 is equals to, we're gonna calculate 180 plus 72.045 0.45 is equals to 252. There you go. 252.045. So our final course is is 252.045. So now we're gonna go to latitude vertex. So there you go. So the formula of the latitude vertex is cos lat vertex is equals to cos lat 1 times sin initial course angle. So first is cos lat 1 is equals to 35 degrees. So what we're gonna do is, so cos lat and cos lat and 35 degrees is equals to 0.81915, and sin initial course angle is equals to 64.493. So we're just gonna sin equals to 64.493. There you go. Is equals to 0.90253. So there you go. So we're gonna times it. So delete it. So 0.81915 times 0.9253 is equals to 0.739 and round off. So it's north because lat 1 and lat 2 is north, so the same sign, it's north, so that's not all. So to get the latitude vertex, we need to 0.73931. So we need to shift and use cos, and answer is equals our latitude vertex will gonna be, so our latitude, so latitude vertex will be, there you go, 42, and of course don't forget the degree. So our latitude vertex is 42 degrees and 38.38, and of course 38.38 divided by 60, so 38.38 divided by, so 0.6, so we're gonna get just the 0.6. So our latitude vertex will gonna be 42 degrees and 19.6, just like this. So the next part is the difference longitude vertex. There you go, longitude vertex. There you go. So our formula is sin dilo vertex equals to cos AC angle divided by synlat vertex. So of course our initial cos angle is equals to 64 and 493. So we're gonna write cos and 64.493 is equals to 0.43062, and our synlat, there you go, our synlat vertex is 42 degrees and 19.6. So synlat 42 degrees and 19.6, so degrees, there you go. So it's gonna be 0.673, of course round off 6, so we're gonna divide these two, there you go. So 0.40062 divided by 0.67336, the answer will gonna be 0.63951 west. So to get the difference longitude vertex, difference longitude vertex vertex, there you go. So we need to 0.63951. I'm gonna go shift sin answer and degree, so 39 degrees and 45 19.05, and of course we need to divide it into 60, so 19.05 divided by 60, so we're gonna get the 0.3. So the difference longitude vertex is equals to 39 degrees and 45.3. So the next one we're gonna get is the difference longitude vertex. So the formula of difference longitude vertex is sin dilo vertex is equals to cos IC angle divided by sin lat vertex. So we're gonna write cos IC angle is equals to 64.493. So again, the calculator. So sin, I mean cos, and 64.493 is equals to 0.43062, and we're gonna write the sin lat vertex is equals to 42 degrees and 19.6. So of course in lat, so 42 degrees and 19.6 is equals to 0.67336. So we're gonna divide it because it's right there in the formula. We need to divide it, so clear all. So 0.43062 divided by 0.67336 is equals to 0.63951 west. So it's like we did. So 0.63951, and of course hold shift and sin answer equals to 39.7. We're gonna press degree. So the answer, the difference longitude vertex will gonna be 39 degrees and 45 and 19.05, and of course we're gonna divide it to 60. So 19.05 divided by 60 is equals to 0.3. So we're just gonna get the first part. So the the difference longitude vertex will gonna be 39 degrees and 45.3, and that's all. So now we will now take the great circle in every 10 degrees. So the first thing we gotta do is to write the departure position, which is our latitude. That is 35 degrees north, and longitude of 7 degrees west. And then we will write the arrival position, which is the latitude 39 degrees north, and the longitude of 74 degrees. So now we will track the great circle in every 10 seconds. So we have 7 degrees. So the next thing is 10 degrees, the 20 degrees, the 30 degrees, the 40 degrees, the 50 degrees, the 60 degrees, the 70 degrees, until we reach the 74 degrees longitude. So that's how you track the great circle in every 10 degrees. And now I will teach you how to get the latitude 1, the 36 degrees and 7.2 north, and the latitude 2, 39 degrees and 7.2 north. So we will now start. So now I will teach you how to get the latitude 1. So you just write first the latitude 1. So we're gonna write long 0, and of course the long 1. So the long 0 is 7 degrees, and always remember that the long 0 is a constant. There you go. And of course the long 1 is equals to 10 degrees 00.0, and of course west. Always forget, don't forget the rule that if it's the same sign, you will gonna minus it. So you're gonna minus it, and if they're not on the same sign, you're gonna add it. So of course we're gonna get the D low. So 7 degrees minus 10 degrees, of course it's 0 degrees. There you go. And don't forget the west. There. And of course we need to write the D low V is equals to 39 degrees and 45.3, of course west. So we're gonna minus it, and don't forget that the D low vertex is constant. It's also a constant too. Then there you go. 39 minus 3 is equals to, of course, 36 degrees. So this is the D low vertex. There you go. And 45.3 west. So to get the latitude 1, we need to apply the following rules, and the following, of course, the formula. So the next formula we need to do is tan that x equals to cos d low vertex times tan lat v. There you go. So I'm just gonna adjust the camera. So of course we're gonna get the os d low vx is equals to 36 degrees and 45.3. So there you go. We're gonna use the calculus. So cos 36 degrees and 45.3. So the answer is 0.80120. The next one is the tan lat. Tan lat is equals to 42 degrees and 19.6. So, and again, we're gonna use the calculator. We're gonna press tan and 42 degrees and 19.6. So, here you go. Of course, it's the answer. The answer will gonna be 0.91078. There you go. And of course, we need to times this too. We need to times it. So 0.80120 times 0.91078. There you go. Is equals to 0.7297 squared. But of course, we're not finished. So we're gonna need to do something to get the latitude one. So 0. Oh, there you go. So 0.722972. So there you go. We're gonna press the shift and tan, and the answer is equals to 36, and we're gonna press the degree. So the answer is the latitude. The latitude 1 is equals to 36 degrees 07 and 8.32. And of course, we need to do 8.32. We're gonna need to divide into 60. So 8.32 divided by 60 equals to 0.2. So our latitude 1 is equals to 36 degrees and 07.2 north. There you go. So the next one, we're gonna get the, of course, the latitude 2. So as just like the same. So the first thing we're gonna do is, of course, write the latitude 2, and we're gonna need the long 0 and the long 2, and the long 0 is 7 degrees west, and oh, it's also a constant. So the long 0 is always a constant, don't forget that. And the long 2 is equals to 20 degrees, and of course west. So just like we did, we're gonna minus it. So this is the dilo. So 7 minus 20 is, of course, is equals to 13 degrees, of course west. And we're gonna get the dilo 5, dilo vertex. So the dilo vertex equals to 39 degrees and 45.3 west. And don't forget that this is also a constant. There you go. And of course, we're gonna minus it. So 39 minus 13 minus 39 is equals to 26 degree coffee, 45.3 west. So we're gonna do is, of course, we also need to get the formula. So this one is so as you can see, this is also the formula there. The tan lat x, tan lat x equals to cos d low vertex times tan that vertex. So we need to get the cos dilo. Cos dilo vertex. I'm sorry. Cos dilo vertex is equals to 26 degrees and 45.3 west. Oh, you don't need west. Then the tan lat of the vertex is equals to 42 degrees and 19.6. So that's how you do it. So of course we're gonna solve them. So the cos d long is 26 degrees and 45.3, which equals to 0.89294. So how about the tan lat? So the tan lat of 42 degrees and 19.6, of course it's equals to 0.91078. So of course we need to times it. There you go. So 0.89294 times 0.91078 is equals to 0.81327. And of course we're not finished, so 0.81327 we need to shift tan and then answer. There you go, and we need to put it in degrees. So the latitude 2 is equals to 39 degrees 07 and 13.76. So of course 13.7 we're gonna need to divide it to 60, and 13.76 divided by 60 equals to 0.2. So now our latitude 2 is 39 degrees and 07.2 north. So now we know how to get the latitude 1, that is 36 degrees and 07.2 north, and the latitude and the latitude 2, that is 39 degrees and 07.2 north. So now we will just need to continue it until you fill or complete all the rows. So now I will show you how to get the course 1 and the distance 1, and I will also show you how to get the course 2 and the distance 2. This the 295 course 1 and the distance 161.43, and the course 2 that is 291, and the distance 2 that is 509.2. So come on, let's start. So now we will find the course 1 and the distance 1. So of course we're gonna get the latitude. Latitude 0 is equals to 35 degrees 00.0 north, and the latitude 1, that is 36 degrees and 07.2 north. And of course we're gonna get d lat, so we're just gonna minus it. So the answer will gonna be 35 minus 36 is 01 degrees and 07.2 north. So we needed to times it to 60. So this 60 is a constant. So this 60 is a constant. So we're gonna minus it. So 1 degree and 07.2 degree times 60. It's equals, so the d lat is equals to 67 degrees 12 or 67.2 north. So there you go. And the next one, we're gonna get the longitude 0 is equals to 007 degrees west, and the longitude 1 is equals to 010 degrees and 00.0 west. And as we did in here, we're gonna minus it to get the d low. So there you go, the d low. So 7 minus 10, it equals to 003 degrees and 00.0 west. And we need to times it to 60 again. Always remember that this 60 is constant. So this 60 is constant. So to get the d low, we need to times it. So 3 degrees times 60 is equals to 180 degree west. And then the next one, we should get now the MP log. It's the MP. So to get the MP, we need the formula. So the formula of MP is log parentheses tan, and of course the lat divided by 2 plus 45 close parentheses and parentheses again times 7,915.7 minus close parentheses 23.3 times sin, and of course the latitude, and again close parentheses. So we need to get the lat 0 is equals to 35 degrees 00.0 north. So to get the MP1, we need to do this, the formula of MP. So again, first is log, then the next one is tan, and of course the latitude 35 degrees, there you go, divided by 2 plus 45 close parentheses times 7915.7 minus parentheses 23.3 times the sin, and of course the latitude again of 35 degrees and close parentheses. So the MP1 is 2230.92. There you go. So the next one is the lat 1. The lat 1 is equals to 36 degrees and 07.2 north. So to find the MP2, we need to follow this formula again. So of course you need to press log, and of course the tan and the latitude of 36 degrees and 07.2, there you go, divided by 2 plus 45, 2 close parentheses times 7915.7 minus, and of course the parentheses 23.3 times the sin, and of course the latitude 36 degrees and 07.2 and 2 closing parentheses. So the answer is 213.6. So we need to get the DMP, we need to minus this 2. So to get the DMP, we should 2230.92 minus 2313.16 is equals to 82.24. So that is our DMP. So the next one we're gonna get is the true course. The next one is the true course. So we'll just move it up a little bit. There you go. So to get the true course, you need to the formula tan course angle equals d low divided by DMP. So the d low is 180 and the DMP is 82.24. So the tan course angle course angle is equals to, so 180 divided by 82.24 is equals to 2.18872. And we're not done yet. So to get the first angle, you need to 2.18872 multiplied 72. So we need to use the shift tan answer, and there you go, 65. So our course angle is equals to 65.44 northwest. So the next one is the quadrant rule. So quadrant rule. To get the quadrant rule, we need the northwest equals 360 minus the course angle and equals to the true course. So NW equals to 360 minus 65.44. So 360 minus 65.44 is equals to 65. No, it's wrong. It's equals to 294.56, or we can do it like 295. So our true course is equals to 295. So then we should get the, of course, the last one, the distance. So the distance is equals to d lat divided by cos course angle. So the d lat is 67.2 divided by cos 65.4. So the distance should be, so here we go, the distance. So 67.2 divided by cos 65.4. The answer we're gonna be 161.43, or we can do it like 161.4 nautical miles. So now we will gonna find the course 2 and the distance 2. There you go. So of course we need the MP again. So the MP, so we need the formula of the MP, the log, tan, and the lat latitude divided by 2 plus 45 close parentheses times 7915 7.7 minus parentheses 23.3 times the sin, and of course the lot and two close parentheses. So the first thing we're gonna find is, of course, we need to put the lot 1 here. The lot 1 is equals to 36 degrees and 07.2 north, and we need to find its MP1. So we need it, so we're gonna going to use the calculator. So the formula is log 10, and of course the latitude of 36 degrees and 07.2, there you go, divided by 2 plus 45 2 close parentheses times 7915 minus parentheses 23.3 times, of course, the sin lat of latitude 1, that is the 36 degrees and 07.2, there you're going to close parentheses. So the MP1 is 2313.16. So we need to, so this is the lot 1, so the next is the lot 2. So the lot 2 is 39 degrees and 07.2 north. There you go. So we need to find the MP2 is equals to, so just like we did, so we need to put here the log, and we need to put the log and tan and then the latitude. So our latitude is 39 degrees and 07.2, oh wait, 07.2, 39 degrees 07.2, there you go, divided by 2 plus 45 close parentheses times 7915.791.7 minus 23.3 times the sin of the latitude 2 is 39 degrees and 07.2 and 2 closing parentheses. So the answer is 2539.50. So to get the DMP, we need to minus this 2, so 2313.16 minus 2539.50 equals to the DMP is 226.34. So always don't forget, so 36 degrees and 39, so we should get the D lot of these two. So first thing, we're gonna minus these two. So 36 minus 39 is, of course, 0 equals to 3 degrees north, and of course we need to times 8 to 60. So to get the D lot, so 3 degrees times 60 is equals to 180 degrees north. So that's how you do it. So the next one we should get is the long one, is equals to 10 degrees west, and the long 2 equals to 20 degrees, and of course west. So to get the D long, we should minus this 2, so it equals to 10 degrees west, and we need to times it to 60. So our D long will gonna be, so 10 degrees times 60 is equals to 600 degrees west. So there you go. So after that, we need to find, of course, the true course. There you go. We need to find the true course. So the formula of true course is tan course angle equals to D low divided by DMP. So equals to 600 divided by 226.34. So to get the tan course angle, we need to divide it. So 600 divided by 226.34 is equals to, there you go, 2.65088. So it's not finished, so 2.65088. so we need to use the shift and tan, and answer will gonna be 69 point. So our course angle will gonna be 69.33 northwest. There you go. So we're just gonna put this down here. Wait, so there. So the next one is the quadrant rule. So the quadrant rule is n double northwest equals to 360 equals course angle. Of course, the course angle is equals to true course. So NW is equals to 360 minus 69.33 is equals to, so 360 minus 69.33 is equals to 290.7, or we can use it as 291. So that is our true course. So our true course is equals to 291. So lastly, so of course we should need to get the distance. So the distance is, the formula of distance is equals to d lat divided by cos course angle. So of course 180, so our d lat is 180 divided by cos of 69.33. So our distance will gonna be 180 divided by 69.33. So wait, so 180 divided by cos 69.33 is equals to 509.2 nautical miles, and that's all. So now I show you how to get the course 1 295 and the distance 1 161.43 and the course 2 291 and the distance 2 of 509.2. So you just need to continue it until you complete and fill all the rows. So the last thing that we need to do and we are going to do is now to get the total distance of the track. So we just gonna do is to add the distance that we need to 161.43 plus 509.2 plus 499.5 plus 420.8 plus 439.3 and plus 452.8 plus 467.5 and 194.3 is equals to 3144.8. So that's how you get the total distance, and that's all. Thank you.